Hi everyone, I hope everyone is doing well. So this video is a continued part of haloalkenes and the haloarenes. So my previous video was about some of the important topics that you have to remember for haloalkenes and the haloarenes. Okay, you have gone through like all the theory part. Okay, you know the preparation method and everything, but there are some points which you might miss. Okay, those important topic on which the question might appear, so I'm giving those points. Okay, at least for some students it might be helpful. Okay, with that intention I'm doing this video. Okay, if you like whatever the videos that I am uploading, if you're finding it very useful, then please do share and subscribe. So usually I'm not going to ask all these things in my any video, but today I thought of asking, so I'm asking. So if you really like the explanation and everything, the shortcut trick that I have given till now, okay, if you really find it useful, please do like, share, subscribe. Okay, fine. So let us move to the continued part of a haloalkenes and the haloarenes, dear students. So I discussed about up to SN1 reaction. Okay, so the SN2 reaction is nothing but what? Bimolecular nucleophilic substitution reaction. Okay, it's a bimolecular nucleophilic substitution reaction. So here what happens? It's a substitution reaction. What are you going to substitute? You're going to substitute a nucleophile. Okay, so here what happens? The rate of a reaction depends on the concentration of alkyl halide that you are taking, at the same time the nucleophile. So as you have learnt in the chemical kinetics, when the rate of a reaction depends on the concentration of any two reactant, then it's a second order reaction. Okay, so SN2 reaction is a second order kinetics. Okay, and it's an inversion of configuration. So in case of a SN2 reaction, if you know the mechanism, what happens? There is a inversion in the configuration. Like if I take an example of umbrella, if the umbrella is like this, okay, so what happens? It will invert. Okay, so it will reverse. So in that way we're going to explain. The inversion of configuration was explained by a scientist called Walden. So it is known as a Walden inversion. Okay, where we will going to observe the Walden inversion? In SN2 mechanism. What is the order of reactivity? That's a primary alkyl halides are highly reactive than secondary than tertiary. Okay, now this is a reaction. So it's a single step reaction. Okay, so here what happens? This is a primary alkyl halide that we're going to take. OH minus is a nucleophile, where the nucleophile will attack the, what we can say, the alkyl halide from the back side, because here already there is a one bulky group present. Okay, due to a steric hindrance, it will going to attack from where the place is available, from the rear side we're going to call. So what happens in the transition state? Simultaneously there is a making and breaking of the bond takes place. A slight COH bond will start forming and CBr bond will start breaking. So finally what happens? We're going to get the alcohol. Okay, so you could see the configuration was like this. Okay, it was like this. Okay, so after the reaction what happened? It inverted like this. Okay, so that's why it is known as a Walden inversion. So this point you have to remember. Now next type of a reaction is known as a elimination reaction, or you could say a beta elimination reaction, and that will going to follow the Setzer. Okay, dear students, this is a very important. Okay, so questions might have, like questions have appeared a lot in the previous exam based on this concept. Okay, so here what is happening? It is a dehydrohalogenation. What do you mean by dehydrohalogenation? D means remove. What are you going to remove? Hydrogen as well as the halide you will going to remove. Okay, that's called dehydrohalogenation. From where you will going to remove? From the alkyl halide. Okay, so here what happens, which is a reagent you will going to use. So whenever you will get a question with a statement like dehydrohalogenation, remember dear students, the reagent is alcoholic potash or alcoholic potassium hydroxide. To remember this one. Okay, and whenever an alkyl halide undergo dehydrohalogenation, the compulsory product that you will going to get is alkene. Okay, alkene. Do remember. Now what exactly the sets of rule will going to state? How will going to apply here? Means, see here what is happening. It's particularly known as a beta elimination. What do you mean by beta elimination? See, the hydrogen is eliminated from the beta carbon. Okay, what do you mean by beta carbon? See, whenever the substituent is attached or the functional group is attached to that carbon, see, I'm repeating once again, there is a carbon, okay, to which the substituent or the functional group is attached. This carbon is known as alpha carbon. Okay, to the alpha carbon, the next carbon that is attached is called a beta carbon. So, but what is happening here? We have a 2 beta carbon, right? So, to this carbon also we have 1 beta, and to this carbon also. So, we have a 2 beta carbon. Now, as I told, it's a beta elimination. Means I had to remove the hydrogen from the beta carbon. So, what is happening here? I am getting 2 beta carbon. Okay, so the hydrogen can be eliminated from this carbon, or the hydrogen can be eliminated from this carbon also. If both the reaction will going to take place, if both the hydrogen atom is eliminated, then which is the major and the stable product? Okay, that you have to see here. So here what happens when I treat this alkyl halide with the alcoholic potash, okay, 2 bromo, which is that butane, okay, with the alcoholic potash, I'll going to get 2 butene and I'll going to get 1 butene. Why the 2 butene is major product? Because it's according to a sets of rule. So how will going to explain that sets of rule? See, when there is a presence of a more than 1 beta carbon, okay, when there is a presence of a more than 1 beta carbon, the hydrogen is eliminated from that beta carbon containing more carbon atoms, or you could say containing less hydrogen atom. Okay, so we have a less hydrogen atom compared to here. So hydrogen atom is eliminated from this carbon, from this beta carbon, so 2 butene. Okay, according to the rule. So here it is the hydrogen is eliminated from this carbon containing a more hydrogen atom. So but 1 is a minor product. So according to a sets of rule, since it is following the sets of rule, obviously this will be the major product. Okay. Now next, ease of dehydrohalogenation among halides. So I have a primary, secondary, tertiary halides. So ease of dehydrohalogenation among the halide will go into tertiary will readily undergo, followed by secondary, followed by primary. This order you have to remember. Okay. Yes. Now, so you saw SN1 reaction and SN2, which are nothing but a substitution reaction, and you saw dehydrohalogenation, which is nothing but a elimination or beta elimination. Okay, so there are some points. Okay, there are some different points regarding a substitution versus elimination. So what are those points? See here, nature of alkyl radical. Okay, primary alkyl halide favors substitution, whereas secondary tertiary alkyl halide favors elimination. So secondary tertiary will readily undergo elimination than the primary one, where the primary will readily undergo what? Substitution reaction. Okay, so effect of temperature, increase in temperature favors elimination reaction. So if we are carrying out a beta elimination reaction, then a temperature also play a very important role. Effect of temperature, increase in temperature favors the elimination reaction. Okay, next one, steric factor. The bulky nucleophile inhibits the substitution and favors the elimination. Yes, okay. So what happens in case of a nucleophilic substitution reaction? If you have a bulky group, that causes the steric hindrance, okay, but that will not play any role in an elimination. Okay, so these are some points. Now let us move to the haloarenes. That is the second part of the chapter. So haloarenes, that benzene ring attached with the halogens. Okay, so we can prepare haloarenes from different methods. So where from benzene diazonium chloride we can prepare the haloarenes by treating with the following reagent. Okay, so here what is happening, if I treat the benzene diazonium chloride with a cupric chloride in presence of a HCl or copper powder in presence of a HCl, I'll going to get chlorobenzene. The reaction is known as Sandmeyer reaction. Okay, so similarly here you could see this, you might have not gone through. So this is called fluoroboric acid. So just a minute. Yeah, fluoroboric acid, and when you heat it you will going to get the respective fluorobenzene. Okay, and the reaction is known as Streamline reaction. Okay, so this you might have not gone through, please remember this one. This is a one method of preparation of the haloarenes. So similarly we can prepare, we have a benzene ring, okay, from a respective benzene by carrying out a halogenation, dear students. Okay, so benzene when undergo chlorination in presence of a ferric chloride gives chlorobenzene, bromine in presence of a ferric bromide gives benzene, iodine in presence of iodic acid gives the iodobenzene. Okay, so these are one method of preparation. And now we have a phenol when treated with a phosphorus pentachloride, we're going to get a chlorobenzene. Okay, and we have a benzene treated with a HCl, and by the oxidation in presence of the cupric chloride at 500 Kelvin gives the respective chlorobenzene, and the name of the reaction is Rashid process. Okay, now we have a what we can say silver benzoate. Silver salts of aromatic carboxylic acid when treated with a bromine or carried out bromination, okay, gives the respective bromobenzene. This is called Hunt-Stricker reaction. Okay, when the named reactions comes to your students, you have to concentrate more on that. Okay, so now when it comes to alkyl halide and the aryl halides are less reactive for the nucleophilic substitution than the alkyl halide. So we saw the alkyl halide will undergo SN1 SN2 reaction and many nucleophilic substitution reaction, where when the same reaction is will going to carry out for the aryl halides, it will not readily undergo nucleophilic substitution reaction. Okay, because of the hybridization, because of the steric hindrance, because of the resonance. There are so many points that you have to concentrate. Okay, now I have iodobenzene when treated with a copper. Okay, that gives diphenyl. Okay, so that name of the reaction is called Ullmann reaction. Okay, this type of a reaction, diphenyl preparation is there. If you remember, okay, that's a Woods reaction, Woods-Fiddig reaction, the Fiddig reaction. So in case of a Fiddig reaction, we have a chlorobenzene in presence of a sodium, dear students. So instead of sodium, if we have a copper, okay, here also we are going to get a diphenyl, but the name of the reaction is Ullmann reaction. Okay, now in electrophilic substitution reaction, see, the haloarenes will readily undergo electrophilic substitution reaction. Okay, so halogenation, nitration, like so many reaction. Okay, sulfonation. So in that case, halogen are electron withdrawing groups. Okay, if we are carrying out the halogenation reaction for the what we can say, the haloarene, the halogen groups are actually electron withdrawing, and as such a non-activating in nature due to minus I effect. Even then they are ortho and para directing in nature due to plus R effect. Okay, the product that we are going to get from the electrophilic substitution reaction of a haloarenes is ortho and para directing, means ortho and para substituted a product. Okay, now we have a chlorobenzene from which I had to prepare a phenol, so which is difficult to break the CCl bond. Okay, so for that reason I'm going to treat with a sodium hydroxide at 623 Kelvin and 300 atmosphere. That gives sodium phenate or sodium phenoxide, which upon treatment with the HCl, okay, gives phenol. This process is called Dow's process. So many questions have appeared from this part. You have to concentrate on this. So how many points like I was able to cover, I have done. Okay, I hope you find this one useful. So my next video will be based on alcohol, phenols and ether. Okay, if you require any such type of videos, Okay, if you comment in the comment box, okay, so then definitely I'll try to upload those videos. Okay, and yeah, thank you.